Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll introduce the trade system to the game. So you can see here on the shop that we no longer have these placeholder texts here, but we have separate traits now available. So if I buy Robin, he's an elf and a ranger, and if I buy Björn, he's a fighter and a Viking. If I buy some XP and buy Harry, he will be an elf and a wizard as well. And if I roll some more XP, I can buy Arthur, who's a fighter and noble. So if I start putting units on the board and put in Robin, you'll see that on the left, it will appear that I have an elf and a ranger on the board, but they will be semi-transparent because none of these traits are activated yet. So for the elves to activate, I need to have 2 of them on the board. If I put in Björn, you see the number of traits will increase, but again, I still don't have any of these traits activated yet. But if I put in Arthur, who's a noble and a fighter, you'll see that the noble and the fighter will be moved to the top because I have 2 fighters on the board. This is highlighted with yellow here. And I have the noble activated immediately as well because Arthur is a noble and nobles only take 1 unit to activate. If I drag any of these units and start moving them backwards, you'll see that these traits will be updated and removed if necessary. And if I finally put in Harry, who's an elf and a wizard, the elf will be moved to the top as well as it activates with 2 units now. Let's see how we can do this. So let's start with the architecture part for the trade system. We have our unit scene as a starting point, which uses the unit stats resource. And we have to introduce a new property called traits. And the traits property will be an array of trait resources, which is a new resource representing one single trait. It has multiple things attached to it. We have basic descriptive properties like the name of the trait, the icon, and the description it has. We have more gameplay related stuff like the different levels the trait can have, the requirements, and the modifiers it applies. We'll also have a couple methods we can use for trait resources. The first will be getting the unique unit count from an array of units, meaning counting how many units from an array possess that trait. We'll also have a helper method called getBBCodeText, which we'll use in the UI for highlighting purposes. And we'll also have a simple Boolean method called isActive, which will return true when the minimum number of units for the requirement is met. We'll also have a static method, which means that this method is not tied to a specific trait resource. It can be called through the class name itself, called unique traits for units, which will do what the name suggests. It takes an array of units as a parameter and returns all the unique traits that can be found in that configuration of units. Okay, so this is all the new stuff we need, the new property for the unit stats resource and a new resource called trait. But we also need to basically implement a new part of the UI. So you can see on the right that we have our arena UI in its current state, and it will instantiate a new scene called traits, which will show all active traits on the board with their correct number of unique units, and it will also handle updating whenever it's needed. And to break it down a bit further, it will also instantiate TraitUI Scenes, which is solely responsible for displaying one trait resource in its current state. This means that one more connection is missing from this visual, which is that the TraitUI Scene will use the trait resource as well. And this flowchart demonstrates how the new resource will add the trait resource will be used by both the unit stats resource and the TraitUI Scene, which is responsible for displaying a trait. And this is how it will look like inside the editor. So we have our traits scene open here on the right, as you can see. And this scene needs to update whenever the game area unit grid changes. So what are the steps to update this UI when the gameplay state or the units on the board change? First of all, we need to get all the unique traits that are currently on the board. Why do we need the unique traits? Well, because if we have Björn, who's a Viking and a fighter, you cannot activate these traits just by putting down 3 Björns, right? So in most of these types of games, one specific unit only counts as one unique trait, no matter how many instances we put on the game board. So that's why I mean unique traits, right? Then when we have that array of unique traits, we need to either create trait UIs or update them if they already exist. So these are 2 very different cases, because if I already had that Viking inside that traits container, then I don't want to delete it and re-edit again, because that would mess with the order of these UIs, right? So if we want to keep the ordering consistent, we have to differentiate between the need of creating new trait UIs because they weren't present before, or updating existing ones. Either way, after we have done with creating and updating all the necessary trait UIs, we need to move the active traits to the top. This is mostly a UX feature, but it's super helpful for players because they can immediately see the traits they activated by putting a unit onto the board. Right? And finally, since we handle creating and updating TraitUI separately, it can also happen that if we swapped out a unit, we need to delete some traits. So if that unit that was swapped out was the last one of its trait, then we do need to delete the TraitUI. So I called these ones orphan traits for this demo, so we need to delete all the orphan traits when we're done with everything else. So without further ado, let's get started. So I have the project open here, and the first thing we want to do before actually starting with the trait system is to create a small piece of UI which shows the current team size or the number of occupied units on the board. I haven't really included this in the architecture part because it's super simple to do. So let's click on the plus sign here to create a new scene. The root node will be another node, so click on this plus sign here and search for panel container. So we can have a nice background for this UI piece. And let's add all the nodes first, and then we can configure everything. So with the panel container selected, press Ctrl A, search for a margin container. With that margin container selected, press Ctrl A again, add a VBox container next. And finally, with the VBox container selected, press Ctrl A again, search for label. And the one final node we need to add is an icon. So let's select the VBox container again, press Ctrl A one more time, and search for texture rect. Okay, so these are all the nodes we need. Let's zoom in a bit to see what's going on better. Double click on the panel container and rename it to TeamSizeUI or something like that. The margin container, VBox containers are fine. Let's rename the label by double clicking on it, call it unit counter or something, and double click on the texture rect and rename it to something like too many units icon. So we want to display this icon when the player puts on too many units on the board, which shouldn't be allowed. So in the future, you cannot enter a battle when you have too many units on the board. You need to somehow resolve this, right? Okay, so let's start by setting the TeamSizeUI panel container size. So with the root node selected, go to layout, transform, and set its size to something like 46 by 24 works fine here. All the other properties can remain the same. I kind of like this semi-transparent dark background we have by default. Then to make sure that the whole content of this UI piece has some margin, let's select the margin container, go to theme overrides, constants, and set a margin to all the size. I'll just use 3 pixels on each side. And now if we select the VBox container, you'll see that this margin will be applied to all 4 sides. Then select the unit counter and type in a text to see how this looks like. So something like 10 out of 10. Make sure to set the horizontal alignment to center, and you can experiment with the vertical alignment as well, but I found that it doesn't really make a difference in this case because it's not big enough to be aligned on the vertical axis too. And here, just to pop the numbers a bit, I'll use a new label settings resource and set up a shadow. So click on the new label settings, go to shadow, and set the color to not a fully transparent black, but something else. And maybe it can be bigger, like 2 pixels. Yeah, I kind of like how this looks like. So when we have the shadow, that's all we really need from the label node. But to make it easier to change this from code, let's right click on it and access it as a scene unique name. Then for the icon, let's select the texture rect. And for the texture, click on the arrow next to empty and quick load a texture and search for warning.png. And you see it immediately that it stretches out because the stretch mode is set to scale. So we can change this to keep us back centered to fix it. And I think we can use the original size. So I don't really want to set the other options because if it's set to keep size, then it will use the original size of the texture, which is 16 by 16. So now the only thing I don't really like is how far apart the label and this icon are from each other. So let's go to the VBox container, go to theme overrides and constants and set the separation to 0 so they are closer to each other. I think this looks much nicer here. And one final thing we need to do is select this too many units icon, right click on it and make sure we can access it as a scene unique name to make it easier to use it in a script. And also we don't really want to display the exclamation mark by default, so we can toggle its visibility so the whole thing collapses to be much smaller. So that's everything we need from the editor side. Press Ctrl S to save this scene, go to scenes, create a new folder, call it something like TeamSizeUI, and TeamSizeUI.tscn is perfectly fine. Click on save, select the root node, click on attach script, TeamSizeUI.gd is awesome, click on create, and let's see how we can do this. And the script will be pretty simple too. First, we provide a custom class name called TeamSizeUI. Then we'll have two export variables. So for this to work, we need the player stats resource and the game area or the arena unit grid. So we can compare the amount of units that are currently on board and compare it to the player stats level property, right? Because if I'm level 5, I can have 5 units on the grid. Then I need two already variable references, one to the label and one to the texture rect for the exclamation point. Then we need to override the ready callback, and what we do is we connect two signals to our update method, which we are yet to implement, and then call that method as well. So we need to update this TeamSizeUI in two cases. Either when the player stats changed, because when they change it might happen because we leveled up, right? And if we leveled up, we need to change it because we can have more units on the board. Also, we need to update it when the arena grid emits the unit grid changed signal, because that means that we either remove the unit from the board or we added one to it. So what do we need to do inside this update method? Well, not much really. First of all, we'll get how many units are currently used on the grid. So we grab the arena grid, we use the getAllUnits method, which returns an array of unit instances, and we'll use the size method to get the amount of units that are inside that array. Then we update the unit counter labels text property, and I'll use two placeholder strings and a slash separating them, just like we use for the test string, the 10 out of 10. And for the first placeholder, we'll put the units used, which is that variable we just stored. And in place of the second placeholder, we use the player stats resources level property, right? The final thing we need to do is we need to determine whether this too many units icon should be visible or not. And basically, it should be visible when the units used on the board is greater than the level property of the player stats resource. If it's less than or equal to the level the player has, we don't have to show this warning image because we didn't go over the limit of the amount of units we can have on the board. Right? So that's pretty much it. We can save this with Control S, and we could test this in isolation, but we don't really have to, since it's much easier to actually instantiate this inside the arena scene, because there we already have access to the arena grid, so it's much easier to test. So let's go back to 2D view, go back to the arena scene, and let's scroll down a bit, and I can make the file system smaller too, so we have access to all our nodes here. And with the UI canvas layer selected, click on this button here or press Ctrl-Shift-A to instantiate a child scene and search for TeamSizeUI.tscn. And you'll see that we have our TeamSizeUI here, but I kind of want this to display in the center of the screen. So let's go to the anchor presets and select the top center one. And if you want to, you can have a couple pixel margin here to make sure that it doesn't stick to the edge of the screen. So let's go to move mode by pressing W, turn off grid snapping with Shift G. And if I start dragging this down and hold Shift, I can move it down maybe 4 pixels. I think that looks a lot nicer. Let's go back to selection mode by pressing Q, turn back the grid snapping with Shift G, and let's assign these export variables. So for the arena grid, click on assign and select the arena unit grid. And for the player stats, let's click on the arrow and quick load our player stats resource. And if we save the scene with Control S and press F5 to run it, or click on this play icon here, and you see we have our placeholder units here, but since those are not registered inside that arena unit grid, we'll see 0 out of 1. So if we sell these and buy a couple units and add this Robin to the arena grid, you'll see it will be 1 out of 1 because I'm at level 1. So if I drag and drop Björn inside, it will be 2 out of 1 and that exclamation mark will display. If I remove Björn, the exclamation point or mark disappears. Awesome. Also, if I buy XP, you'll see as I level up, this information will update accordingly. So now I can drag these units around and keep track of the team size UI we have here. So that's everything we need from this piece of UI. So we can move on to the trait system next. And to do so, we'll need to create a new resource for the traits. Let's make our file system doc a bit bigger. And inside our data folder, we can collapse units and unit pool for now. Right click on data, create a new folder, call it traits, right click on the traits folder, create a new script, and I'll call this trait.gd and make sure that it inherits not from the node class, but from the resource class. Click on create, expand the folder and double click on it to open it up in the script editor. And the first thing we'll do is we'll provide a custom class name called trait. Then we'll have a constant called highlight color code, which will be an RGB code we want to use to highlight the currently reached or activated level inside the trait. Then we have 3 export variables, one for the name, one for the icon, and one for the description. Then we have another batch of export variables that are more gameplay related. We have one integer, which determines the size of the following 2 arrays. So levels here mean how many different levels can activate inside the trait. So let's say you have a trait called fighter, which has 3 different levels. The first level needs 2 fighter units, the second level needs 4 fighter units, and the third level needs 6 unique fighter units, right? In this case, levels is equal to 3, as there are 3 different thresholds you need to meet in order to activate the higher level of the trait. So then we have unit requirements and unit modifiers, and these will be arrays that need to match the size of this level's export variable you have. So if you have 3 levels, you need to have 3 unit requirements like 2, 4, and 6 from the previous example. And unit modifiers is sort of just there as a placeholder. We don't really have the modifier system yet in place, but in the future or season 2, when you activate a trait, you want to apply modifiers to the units, right, to give some bonuses. Then we have the methods we talked about in the architecture part. The first one being getUniqueUnitCount, which needs an array of units as a parameter and returns an integer with the number of units that possess that trait. So first of all, we'll need to call the array.filter method to filter through the units. And for each of those units, there will be a new unit stats property called stats.traits, and this will be an array, right? An array of trait resources. So what we can do is we can use the has method for that array and check for ourselves as a trait. So imagine that we are inside the fighter resource, right? And we call this method with an array of units. So for each of those units, we'll check what traits they possess based on their stats and check if that array has the fighter resource, because self in this case refers to the fighter resource. And after we filtered through all of these units, you could say that, okay, we can just return the size of that array, right? Because we have the number. Well, not really, because remember, we need to count the unique units that possess this trait. So what we need to do is we need to create a new array called unique units, and we can just use the unit names to identify the unique ones. This array will be empty by default, and we need to loop through the filtered version of the units and only append that unit name to this unique units array if it wasn't there before. This way we can make sure that if we have 3 Björns on the board, it won't be counted as having 3 different fighter units. And when we are done with that, then we can finally return the unique units array's size with the return statement. Then we have this getLevels BB code, which takes the unit count as a parameter and returns a string. We need this because we'll use a rich text label node inside the TraitUI Scene to indicate which level is active, if any at all, from all the possible levels that trait has. So what we do is we build a string array of these level requirements. Again, take that example of having 2, 4, and 6. First of all, we need to determine based on the unit count parameter which level we currently reached, right? So what we do is we take the unit requirements array, which is a property we have, and that array would contain 2, 4, and 6 in this example. We filter through all of these values and only return those that are reached by this parameter. So if we pass in 5 as the unique fighters count, then this reached level array will contain 2 and 4, because in comparison, 5 is greater than or equal to both 2 and 4. So then we can loop through all the levels that are available. So in the case of 3 levels, I will be 0, 1, and 2, right? So we can either simply append the number to this code array as a string if it's not the last level we reached. So let's take this example again. If we have 5 units and the fighter has 2, 4, and 6 as requirements, the first requirement will be 2. It's true that we reached that, but we don't want to highlight that value because there's a bigger one that we already reached. So in this case, this else would execute because I won't be equal to the reached level array size -1 because that will be 1. So what we do is we simply append 2 to the array. In the case of 4, that's the last one we reached. So this Boolean expression will be true. And in this case, we'll use the BB code to again append the number, but this time we'll use the color tag to highlight it with a different color, and we'll use 2 placeholders. The first placeholder will be the hexadecimal color constant we have, and the second placeholder will be the unit requirements arrays element at the I index, meaning 4 in the example, right? So we have 2 and 4 inside that array, but 4 will be highlighted with this yellow color. And when we continue with this for loop, the final number will be 6 when I equals 2. Again, this Boolean expression will be false, so we just simply append 6 to this array, which means that we have built an array of 2, 4, and 6, and the 4 will be highlighted with a yellow color. Then we can use the strings join method to take that array of strings we have, 2, 4, and 6, and join them by slashes. So the final string will be one string where all the numbers will be separated by slashes, and if there's an active level we reached, then that will be highlighted with yellow. The next method we have is called isActive, and it takes the unique unit count as a parameter and returns a Boolean, and it's pretty simple. In order to determine whether a trait is active or not, we need to take the unique unit count and see if it's greater than or equal to at least the first unit requirement, right? In the case of 2, 4, and 6, we can say that the trait is active if we have at least 2 units, because that's the smallest requirement. It can be bigger than that, but this isActive is only concerned with whether we activated it at all, right? And finally, we have this static function called getUniqueTraitsForUnits, which is a static function because it's not tied to one specific trait. So all of these other methods we have defined work for a specific trait, right? So I can generate the BB code for the fighter trait or for the human trait. I can get the unique unit count for elves, right? Because it uses self. But this final method called getUniqueTraitsForUnits will take an array of units and get all the unique traits that are available. That's why it returns an array of traits instead of one, right? So what we do is we define an empty array called traits, then loop through all the units that were passed in as a parameter, and just loop through all the traits that the unit has, because the unit stats, again, will have a traits property, which will be an array of traits attached to that unit. In the case of Björn, for example, it will be fighter and Viking, right? So we loop through all those traits, and we only append it to the unique traits array if it wasn't there before. So we use that to ensure that all of these traits that are inside that array will be unique. And when we are finished with all of those units, we can return that traits array, which will contain all the unique traits that this array of units possesses. Okay, so that's all the code we need from the trait resources script. Let's save this with Ctrl S. Okay, so let's create those trait resources next. Let's go back to 2D view, and inside our traits folder, right-click on it, create a new resource, and search for trait.gd. And we'll add them one by one. I show you a couple ones and then speed up the video to make sure that it doesn't take up much time. So let's start with the elf trait. Type in elf.tres and click on save or press enter. Double click on the resource to open it up in the inspector. For the name, we can type elf with a capital E. For the icon, we can press load, go to our assets folder, sprites, and traits, and you see we have all these icons here, and the names are matching the traits. So you can actually use quick load for the next ones. I just wanted to show you. Double click on elf. The description, I'll leave it empty for now, and you can play around with the levels. So for the elves, I'll just say 2 levels. And for the unit requirements, I have to set this to 2 as well to make sure that it matches this number. And to activate, we need 2 elves. And for level 2, let's say we need 5 elves. For the modifiers, again, we'll use a 2-element array to match this number. But for now, we can leave it empty as a placeholder, right? So that's how you can create one of these resources. And I'll just speed up the video and do all the other ones. Okay, so that's all of those done. Press Ctrl S to save them. And now we have our traits ready to go, but we need to assign them to units, right? So if I expand the units folder and double click on Björn, we don't really have an export variable to assign the traits. So that's what we're going to do next. Let's go to the script tab, press Ctrl Alt O, and search for unit_stats.gd. And here, just above or under the pool count, under the data category, we can introduce a new one called traits, which will be an array of trait resources. So if we save the unit stats script by pressing Ctrl S, go back to 2D view, now we can actually assign traits to units. So if I double click on Arthur, you'll see that we have this traits export variable where I can assign as many traits as I want to that unit. And you can mix and match however you want to. I just use 2 traits for Arthur, and you can either drag and drop those traits or you can use quick load if it's faster. So I'll just say that Arthur will be a fighter and noble. Björn will have 2 traits as well. It will be fighter and I think the other one should be Viking, but I haven't done the Viking resource. Yeah, so let's do another trait. Right click, create a new resource. Trait is fine, call it Viking. Double click on it, call it Viking. For the icon, quick load Viking.png. And let's say that you need 2 levels for this, 2 and 3 maybe. And you'll have 2 modifiers in the future. So if I click on Björn now, I can say that he's a fighter and a Viking as well. Björn test, we can leave it as is. For Robin, again, we can assign 2 traits, an elf and ranger. And just to make sure that we can actually activate a couple of these traits, let's create a new unit I have in my reference project. So let's right click on the units folder, create a new resource, search for unit stats.gd, and I'll just call him Harry. So Harry will be an uncommon unit with a gold cost of 2, and the traits will be wizard and also elf. Maybe we can swap these just to make sure that it looks organized. We can set the pool count to whatever we want it to, but let's not forget to set the skin coordinates. If we open up our assets folder, sprites and rogues, and if we double click on it, I want to use this sprite. So you'll see 0, 1, 2, 0, 1, 2. So the skin coordinates will be 2 and 2 respectively. So if we scroll back down and double click on Harry, the skin coordinates will be 2 and 2. And now that we're done with Harry, let's not forget to add him to our unit pool. So if we filter through our files and search for unit_pool, you'll see that we have Arthur, Björn, and Robin. So let's increase the size of this array and quick load harry.tres. Okay, so now if we save this and run the game, what happens is that we have those traits assigned, but you'll see that Viking Fighter will be displayed for all of these units because we haven't actually hooked up these labels to the trait system for the unit cards because we haven't had them, right? So that's one thing we also need to do. So let's press Ctrl+Shift-O and search for the unit_card.tscn. And we have our traits label ready to go as a scene unique name. So we just need to change this, right? Based on what we have. So let's click on the script icon for the unit card. And here, if we scroll down to set unit stats, this is where we change everything basically, right? So we somehow need to set the traits labels text property, right? How do we do this? Well, we can write a for loop here, or we can create a new method somewhere. I'm not entirely sure what makes more sense in this case. I don't think it matters that much. But what we can do is we can go back to the trait script and actually create a new static function to solve this problem for us. In my reference project, I actually did this in the unit stats class, but now that I think about it, I think it makes more sense to implement this functionality here. So basically what we want to do is we have an array of traits for the unit stats, right? And inside the unit card, we have access to our unit stats resource. So what we want to do is we want to grab all of the names for the traits and want to join them by new line characters, by enters basically, right? So they are displayed under each other. So I think it makes sense to do this inside the trait as like an accessible static function because it's more connected to the trait's responsibility I think. So let's create a new static function called getTraitNames. And what it does is it takes an array of trait resources and returns a packed string array. And what we do is we create an empty array and loop through all the trait resources and append the current trait's name to that array and return it. So pretty simple stuff. And now that we have this as a static function inside the trait class, if we save this with Control S, go back to our UnitCard, what we can do here is say something like traits.text should equal to a new line character joined by a packed string array, right? So what this does is it takes all the strings as the parts of this array and joins them by new line characters. And now we can just say trait.getTraitNames, and we need to pass an array of traits as a parameter, and we can just say unitStats.traits. Right? Because this will be an array of traits. Cool. So now if we save this with Control S with this extra new static function and that one line of code inside the unit card, if we play the game again or press F5, we no longer have these placeholder texts. You'll see we have fighter, Viking, elf, ranger. So all the trait names are displayed correctly. If we roll for Harry, elf and wizard will be displayed. And if we roll for Arthur, fighter and noble will be displayed. I don't know if I like using capitalized letters. In the reference project, I used all lowercase, but you know, that's something you can just change in the resource for the name, so it doesn't really matter that much. Use whatever you like. Okay, so now we have everything set up to actually do the trait management system, the TraitUI scene, and then the traits scene. So that's what we'll do next. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Okay, so next up we can do the TraitUI scene. So let's go back to 2D view. Click on the plus sign to create a new scene, and we'll use another node as a root node here, namely a panel container. And again, let's just add all the nodes, right? Do the hierarchy first, and then we set up everything. With the panel container, the root node selected, press Ctrl A to add a child node and search for margin container. Then with the margin container selected, press Ctrl A again, search for a VBox container. Inside that VBox, press Ctrl A again, add an HBox container. Inside that HBox, press Ctrl A, add a texture rect. And inside that texture rect, we'll add another texture rect. So press Ctrl A again, add another one. And if we select the HBox container, and these are basically the icons, which is the top left of this whole UI, and next to it, inside that HBox container, we'll press Ctrl A again and add a VBox container, because next to the icon, there will be the number of active unique units and the highlighted version of the levels requirements. So that's why we need a VBox here, press Ctrl A again, add a label node first, select that VBox again, press Ctrl A, and add a rich text label under it. We'll use the rich text label to make sure that we can highlight with yellow the active level that is reached by the units. Okay, and we have a VBox container here, which currently only has one child, that is that HBox container. So this whole upper part of the trait UI will be the icon here, and next to it will be the number of unique units and all the level requirements with the highlights. But under them, we want to display the actual name of the trait. So with the VBox container selected, press Ctrl A, add a margin container to make sure that we have a nice little margin, press Ctrl A one more time, and add a simple label displaying the name of the trait. Okay. So if we expand everything, make sure the smile system is a bit smaller, this is how the whole hierarchy looks like. Now let's start by renaming things accordingly, right? Double click on the panel container, the root node. Let's rename this to TraitUI. Select the first texture rect, and this will be the trait icon background. Select the inner texture rect. This will be the trait icon. And this we want to change dynamically. So let's right click on it and access it as a scene unique name. Then for the first label, we can rename this to active units label. Again, this is something we want to access from code, so right click on it, access it as a scene unique name. For the rich text label, we'll use the name trait level labels. And finally, for the name of the trait, we'll just use trait label. Again, I forgot to do it with the rich text label, but these two labels will be accessed as scene unique names to make sure that it's easy to reach them from code. Okay, now let's set some stuff up. So we can go in any order, basically. Let's start from the bottom now. So the trait label, we can type in some test text, something like ranger. And you'll see that this font is way too big for this purpose, I think. So let's create a new label settings resource. And we'll use the other font we have. So under font, this empty should be replaced with a quick load, and we'll use this M5x7 font we have. You see, it's much smaller. I think it fits better for this purpose. And also we can add a 1 pixel shadow just to make sure that it pops out from the background. I use this fully opaque version. Yeah, I think it looks nice, but we do have to set up this margin container we have because it looks kind of weird, right? That it touches the edge of the whole container. So to make sure that it looks nicer, select the margin container. And the one thing I want to change here is to set a margin on both sides. So go to theme overrides and constants and set the left and the right margins to whatever value you like. I just use 2 here on both sides. And now we can move on to the rich text label. So you'll see that this is very small by default. So let's type in some testing text, something like 2/4/6. Let's make sure that we enable BB coding so we can use the color highlight we wanted. Toggle scroll active off because we don't want any scroll bars here. And under layout and custom minimum size, we can set a minimum size value because you see rich text labels doesn't fit their content by default. So let's do something like 28/16, I think should be enough. But you see, again, we use this very big font, which is not really suitable for this purpose. So if we scroll down to theme overrides, we have a bunch of stuff we can change for rich text labels. Let's start with the fonts. So the normal font will use quick load to load this M5x7 font again. And you see now the text fits. So fonts are done. We can configure colors. So for the default color, I want to use something other than white. So to make it less accented, I use a gray color like this one. And also under font shadow color, I use a black shadow to make it pop out a bit more. And it already starts to look a lot nicer. Also, we can turn off clip contents under the layout to make sure that everything fits fine. And I think that's all we really need from this rich text label node. Now for the active units label, we don't really want to change much. If we use some testing code like 1, it kind of looks okay. I think it's fine to use this bigger font for this purpose. One thing I want to change is actually align it to the bottom. If it ever gets bigger, I want these two to be as close to each other as possible. But if we want to, we can also add a shadow here. So create a new label settings resource and apply 2 pixel shadow and use some semi-transparent black maybe. Yeah, I think it adds a bit to it so it can stay like this. And what I definitely want to do is select this VBox container where these 2 labels are put together, go to theme overrides and just set the separation between them to 0 to make sure that they are close to each other. But you see, they're still pretty far away. So I want them to be nice and tight. So we can also use a negative separation value here. And I'll just use -4 or something like that. In theory, they will overlap if you take a look at the bounding boxes, but you see that it's not really an issue here. And I kind of like how they are closer together now. Okay, so we are already starting to see that it looks a lot better. Let's do the other ones. So for the trait icon background, the outer texture rect, let's click on texture and quick load our trait icon background.png. And for this one, we can keep the original size because that's the size I actually want to use here. We can see that it's 1 tile big, so 32x32. To make sure that it never stretches, though, we can set the stretch mode from scale to keep aspect centered. And inside that background, we can click on the trait icon now. Quick load the texture to test. I'll just use, I don't know, the elf icon. And you'll see that this is way too big. So we have to use a different size compared to the original. Instead of keep size, we'll use ignore size and the stretch mode to keep aspect centered. And inside layout and transform, we can set the size to 24x24 and the custom minimum size to 24x24 as well to make sure that it never gets bigger or smaller than that. And now we just need to center it right inside this other background image, but that's pretty easy to do. We can just set the anchor preset to center, right? And it will be centered compared to the parent, which is awesome. In this case, that's exactly what we want. And now it's just a matter of tweaking the containers so this whole thing doesn't look too bad. Let's start with the HBox container, this one. I think we can set the separation to, well, 0 is a bit too close in this case. I don't know, maybe we can leave it at the default value for now. But this VBox container separating those two from each other should be definitely set. So let's go to theme overrides and constants, set the separation to 0. Again, I kind of want those two to be even closer to each other. So I just use the negative value here. Yeah, I kind of like -2 for this. And the final thing we need to do is to give the whole thing some breathing room, right? Because they are just too close to each other as of now. So let's select our final margin container, go to theme overrides and constants and use a margin value that makes sense to you or what you like. Here, I'll just use 2 pixels left, or maybe even more. 4 pixels left, 2 pixels top, 4 pixels on the right, and 2 pixels bottom. Yeah, you see what difference it makes? It already looks a lot nicer. And I think that's all we really need from the editor side. If we select our root node, we can check the transform to make sure that it's small enough so we can fit a lot of these on the left side of the screen. And if I zoom out, so at 100% zoom, you see this is what it looks like in comparison to the screen. I think that's fine. So yeah, that was a lot of editor fiddling, but that's just the case with UI, right? So let's not forget to save this. Press Ctrl S to save it. Let's go back to the root folder, click on scenes, create a new folder, call this trait_UI, and trait_UI.tsn is perfect. Click on save. And now we just need to make this come alive with a script. So with the root node selected, click on the attach script button, and TraitUI.gd is perfectly fine. Click on create, and let's see how we can do this. Okay, so tracking one trait won't be that bad, I promise. So the first thing we do is we provide a custom class name called TraitUI. Then we have 2 export variables, one for the trait data, which will be a trait resource with its own setter function, and we'll also have an export variable called active, which will be a boolean, again with its own setter function. Then we have already variable references to all the dynamic data we need. We have the icon, a texture rect node, we have 3 labels, one for the active number of unique units, one for the levels, the rich text label thing, and one for the name of the trait itself, which is the bottom part, right? So we'll provide a public method called update, which takes in an array of units and updates the trait UI according to those units. This will be useful because we can just basically pass the units on the board to each of these trait UIs and they can update themselves accordingly. So what we do first is we grab all the unique units that are applicable for this trait. So we'll use the trait data resources get unique unit count method, which we provided earlier, and say that, okay, if I'm a trait UI representing the fighter trait, then these are the array of units that are available and give me how many unique fighter units are on the board. And when we have that number, we can basically update the active units label text, which is the biggest one, right? And that will give us how many fighter units are on the board currently. When we have that number, we can also update this level requirement rich text label, which is divided by those slashes, right? And for that one, we might need to highlight one of those requirements if we already meet them. And this is why we did that BB code returning method inside the trait resource class. We can just pass in the amount of unique units we have, and we'll get that BB code back from the trait resource, and we can just override it inside the rich text labels text property. And finally, we also need to set the active property for the trait UI based on whether it's active or not according to the amount of unique units we have. And this is again a method we have inside our trait class. Let's not forget that setting this active property will also trigger its setter function, which we are yet to implement. So what about those 2 setter functions? First, when we set the trait data, we basically need to update anything. But before we do that, because it's an export variable, if the node is not ready inside the scene tree, we need to wait for it to avoid any crashes. But if it's ready inside the scene tree, we can update the trait data to the new value. And then you might think we need to call the update method, but just changing the trait resource for that trait UI doesn't mean that we have access to the array of units currently sitting on the board. But what we can update is the icon and the name of the trait we have, right? But since we don't have any information related to the amount of units that are on the board with that trait, we can only update these 2. And we also need to implement the setter method for the active boolean checkbox. And the first thing we do is we set the active property to the new value. And then to make sure that the active traits pop out a bit more, we set the modulate properties alpha value to either 100% if a trait is active or 50% if it's inactive. That is just again a visual decision, a UI UX decision to make sure that these active traits are not just moved to the top, but also pop out a lot more than inactive ones. And that's all the code we really need for the trait UI. We can save this with Control S, and we can kind of test how this works, but not the update method yet. But we can test the setter functions if they work or not. So let's go back to 2D view. And with the trait UI selected, you can see that we can change the active and the trait data export variables. Let's load the trait data. So click on the arrow here and quick load whatever we like. Let's quick load the Viking. And if we run this scene by pressing F6 or clicking on that button, you'll see that it's indeed updated. So we have the new icon, the new text. And this is not updated. These are the default values we provided because, again, just by setting this trait data, we don't really have access to the units that are currently on the game board. So what we can also test is the active property. So if we go to the remote scene tree and click on this trait UI, we can toggle active on. But this does nothing because it was on by default. It was visible by default. But if we toggle it off, then the setter function gets called and that 50% transparency applies. If I toggle it back on again, you'll see that it pops up again. So both of those things are working as intended, but just by changing the trait resource, the trait data resource, we can only update the icon and the name, not these other two values. So let's close this for now and see if we can add any testing code inside the script tab that helps us to test this update functionality as well. Let's add something like this. When we press the enter button inside the input callback, we'll create two new units dynamically when the game runs, and we assign Robin's stat to one of those and Harry's stats to the other one. And then we call the update method with 5 units, namely 2 Robins and 3 Harrys. So in order to test this, it is recommended to use the elf trait because these are both elves. So let's save this with Control S, and if we go back to 2D view, select the trait UI again, and instead of using the Viking resource, let's just quick load elf.tres. Now if we run the test scene again or press F6, you'll see that we have our elf icon and the elf name. And when I press enter, you'll see that it updates accordingly. It recognizes that we have 2 elves and we have this level requirement of either having 2 or 5 elves to activate bonuses. And since we meet the requirement of having 2 elves, this will be highlighted with a yellow. So everything works fine. If we close the game and change the requirements for the elves to have at least 3 of those to activate and test the scene again, I press enter now, you'll see that it will be transparent because it's inactive. We only have 2 elves and we need at least 3 to activate. And one final thing we can test is if we change the requirements to 1 and 2 and test it again, press enter now, you'll see that I'm at the level 2 requirement, so this one will be highlighted, right? Because we don't just activate it by having 1 elf, but we have 2. Awesome, so it seems like everything works perfectly fine. We can put this back to 2 and 5 or whatever value we want to. And if we are confident that it works, we can go back to the script tab and just delete all these testing code we added. And we need to make sure that inside our traits scene, which will be this sort of conductor that manages all the trait UIs, we have to update each and every one of them representing their own traits. So with this saved, the trait UI is ready to go and we can move on to the traits scene next. Okay, so now we just need to make sense of sort of creating and updating all these trait UIs according to the game's current state on the game board. So what we do is we create this new scene called traits. So let's click on the plus sign to create a new scene. And this time the root node will be a simple user interface node, a control node, but we can double click on it and rename it to traits. And inside that traits control node, press Ctrl A to add a new child node, and we'll add a VBox container, which will contain all those traits. And we can double click on this container and rename it to traits container. And just to make sure that we can always access this, we can right click on it and access it as a scene unique name. And to get a feel of what this will look like in game, we can instantiate a couple of trait UIs. So press Ctrl Shift A or click on this button and search for trait UI.tscn. And we can just press Ctrl D to duplicate this like 2 or 3 times. And this is what it looks like. I kind of like the default separation between the different UIs. What I don't like is that the container is sticking to the top left corner of the screen. So let's just go into move mode by pressing W with the trait container selected, start dragging this around, and I'll just move it 4 pixels on both axes. And it seems like a small thing to do, but it does make a big difference in my opinion. But I'm no UI expert, so you can just do whatever you like. Let's go back to selection mode by pressing Q. And that's all we really need from the editor side. So let's save this scene by pressing Ctrl S. Go back one folder, and inside our scenes, we can create a new folder called traits and save it as traits.tscn. Click on our root node, attach a new script to it, click on create, and see how we can code this. Okay, so now I need you to buckle up and make sense of this code we want to write here. First of all, we'll provide a custom class name called traits. Then we'll provide a constant called TraitUI, which will be the TraitUI Scene preloaded, so we can instantiate it dynamically whenever we need to. Then we'll have an export variable to the arena grid, because again, we need to update all the TraitUIs when the arena grid changes, right? Then we have one already variable reference to the trait container, the VBucks container we have, so we can delete or add TraitUIs as needed. And then we have 3 member variables, a dictionary called current traits, an array called traits to update, and an array called active traits. Let's stop here for a second and let me show you why we need those. So if you remember, we looked at this flowchart at the architecture part of the video, and we'll focus on the first 2 steps here. Get all unique traits on board and create/update all TraitUIs. So let's say we start with this empty unit grid, okay? Now we have our current traits, which is a dictionary, our traits to update, which is an array, and the active traits, which is an array again. So these are the 3 member variables we need. What happens when we add a new unit to our empty board or grid, right? Let's say that we add a Björn. In this case, Björn is a Viking and a human or whatever else. So we'll add those 2 traits to the current traits dictionary. And this means that since we didn't have UIs representing the fighter and human traits, we need to create those new trait UIs, right? So to add them in the dictionary, the keys will be the traits themselves, in this case fighter and human, and the values will be trait UI instances representing those traits. Specifically, trait UI instances that are instantiated under our VBucks container, right? Okay, so in this case, we needed to add both of those and the other arrays are still empty. What happens now if a Robin comes in to our game board? Well, first of all, our dictionary will not be empty anymore. So we need to recognize that, okay, we already have trait UIs inside the dictionary and those will need to be updated instead of recreated again. So we'll add the 2 keys to our traits to update array. Now we have to update all the pre-existing ones, but there are also new traits that need to be added, right? So this is what I mean by create/update. In this case, we have to create one new trait, let's say the elf. Again, we add it to the dictionary. So the elf will be the key and the new trait UI will be the value. And since we have that, we added the new elf trait. And now we need to update the fighter and the human ones, right? Because they were already pre-existing. So after we update them, we can delete them from this array called traits to update because it only stores traits that are still need to be updated. And after we do the update, we no longer need to update them, right? And just so it happens that both of those stay the same because Robin is neither a fighter, neither a human. The active traits is still empty because none of these activated yet, right? Because we only have one of each. So what happens when a second Robin comes in? We take a look at our current traits dictionary and see that, okay, we actually don't have to create any new ones because we just added a Robin. But we do need to update all the pre-existing ones. So we need to update the fighter, the human, and the elf trait UIs. But the update itself yields no change because remember, we only count unique units. So what happens is all of these traits will be removed from the traits to update array, but none of these will really change because we only have one elf since 2 Robin units are still considered to be 1 unit. Okay, now what happens if an Arthur comes in? Well, since Arthur is a fighter and a noble, noble is a new trait UI that doesn't really exist in the dictionary yet as a key, so we need to add it, which means that we add the new key and instantiate a new trait UI that represents this trait. So now we have 4 trait UIs, and basically we need to update all 4 of them. And what happens is when we do the update and delete them from this array, it means that the fighter trait UI will be updated, because now we don't have one fighter, but we have 2 in the form of Björn and Arthur. So it means that we have 2 fighters which will activate the trait. And we also have the noble trait activated because it only requires 1 unit. So fighter and noble will be added to our active traits array. Hopefully it makes sense what I'm proposing here, okay? So let's see how we can do this in code. First of all, inside the ready callback, we need to connect to the arena grid's unit grid changed signal so we can update all the traits every time the unit grid changes. And also inside the ready callback, I advise looping through the trait container and deleting all the trait UIs because we added those as just placeholders to see how this whole thing looks like inside the editor. Okay, but probably the most interesting part is how that update traits method works. So first of all, in the case of each update, we start by assigning the traits to update array based on the keys of the dictionary, just like we saw in the visuals. In the case of an empty grid, this will be an empty array because our dictionary is empty, right? As for the active traits, we always begin with the assumption that we have no active traits available when we initialize a new update. Then we need to grab all the units from the arena grid. Then we use that trait.get unique traits for units static method, which will return us an array of all the traits that are currently available on the board. And this is great because then we can use this as a starting point, right? We can check, do we need to create this specific trait or do we have this already and we just need to update it? And that's exactly what we do. We loop through the traits array for each trait resource and check if we have that resource pre-existing in the dictionary. Because if we do, we only need to update it. But if we don't, that means we need to create a new TraitUI scene. So we call 2 different methods here based on whether we already had this trait or not. Both of those we are yet to implement. And then we do the final 2 steps of the flowchart, which is moving the active traits to the top and then deleting the orphan traits we have. I'll show you why we need those in a second. So how do we create a new trait UI when we need to? We basically need to have access to that trait resource we want to create the UI for and the array of units that are currently on the board. And what we do is we instantiate a new trait UI based on that constant. We add it as a child to the container, set its trait resource export variable, call the update method to update the information immediately. And also, this is super important, just like we saw in the visuals, that we need to add this to the current traits dictionary. So after we created one, we add it with the trait resource as a key and the trait UI instance itself as a value. And what about updating? So how is it different from creating a new one? Well, first of all, we don't need to instantiate anything because we already have that trait UI instance ready. We just need to grab it from our dictionary, right? We use the current traits dictionary and we can use the resource itself as a key. The value will be the trait UI instance, so we can store this in a variable. Then we can call the update method, just like we do when we create it. But then what we also did in the visuals is that we erase it from the traits to update array after completing that update, right? And I'll come back to why we need this in a second. Also, a big difference here is that if the trait UI becomes active after updating it, then we can append this trait to the active traits array. We need to keep track of the active traits because we have this step that we want to move all the active ones to the top when we finished updating each and every one of those. And in order to do this, we need to have access to all the active traits so we can move all of them to the top. So how do we move them to the top? Well, after we finished an update, we need to loop through all the active traits, that array of active traits, grab the according TraitUI scene or instance from our dictionary, and we can call the move child method for the trait container and say that this instance should be moved to this position. That's pretty much it. And the final thing we need to do is to delete orphan traits. So what do we do here? We loop through all the traits to update and basically delete all of those and release them from the dictionary. Why can we do this? Wouldn't we accidentally delete traits we actually need? You have to really carefully wrap your head around this and think about the flow of events, right? When we start the whole update sequence, we say that all the traits need to be updated that are currently present inside our dictionary, right? Let's say we have a Björn and Robin. and an author, for example. So we have Viking, Fighter, Elf, and Ranger as traits, right? So what happens is all of those traits will be created previously, and if I remove Björn, then the grid area changes and the next update will be queued. So the current traits will still have Viking, Fighter, Elf, and Ranger, right? The active traits will be an empty one. Then we grab all the units from the arena grid and get the unique traits that are available. So for the dictionary, we still have Viking, Fighter, Elf, and Ranger, or whatever. And when we loop through the different traits, since we removed Björn from the board, these unique traits will no longer contain the Viking trait. We'll only have Elf, Ranger, and Fighter or something like that. But the Viking will definitely won't have. So then we basically won't create any new trait UIs since no new unit was added, but we need to update our Elf and our Ranger and our Fighter traits. Then we move all the active traits to the top, and the Viking trait is kind of hanging there, right? Because it wasn't part of this loop, because we only loop through the current unique traits we have on the board, and it was just Elf, Ranger, and Fighter. So Viking was not a part of this, so we actually did nothing with our Viking trait, but it's still a part of that traits to update array, because when we started, we copied all the keys from our dictionary, and previously, Björn was still part of the board. So after we move all the active traits to the top and did all the updates, remember, when we update a unit, we remove it from the traits to update array. And this means that this array had all the keys from the dictionary to begin with, the Viking, the Elf, and the Ranger, and the Fighter. And since we updated the Elf, the Ranger, and the Fighter traits, those will be erased from the array. So by the time we arrive at this delete orphan traits method, the only ones remaining in the traits to update are basically orphan traits, right? So it was there because it was part of the dictionary, but since we removed Björn, it wasn't updated. So we can be sure that anything that still hangs there by the end of the whole algorithm can be deleted and considered as an orphan trait. So deleting it takes 3 steps. First, grabbing the trait UI that's corresponding to it, and then erasing it from the dictionary to make sure that it won't be there for the next update, and then calling Q3 on the UI node itself to make sure that it's visually deleted from the game as well. Hopefully that makes sense. That's all there is to it, so we can save this with Ctrl S. But let me show you a visualization why we need these 2 last steps. Hopefully that helps you to understand what would happen if we didn't have those 2 steps. So this is what it looks like when we don't have move active traits to the top. You see the Elf activates, but it would help a lot if it was moved to the top, right? So if we do have move active traits to top, this is how it looks like instead. When we drag Harry over, you see that the Elf bumps up to the top and it looks a lot nicer. For the delete orphan traits, this is what happens when we don't do it. So if we buy a couple of units and drag them over to the game area, you see I add a couple of units here, and if I remove Björn, you'll see that the Viking is still there and the Fighter as well, right? So we won't delete them because they will still hang around in the dictionary. But if we do have that delete orphan traits method and we'll put all the units on board, you'll see that when I remove Björn, it immediately updates and deletes all those that are no longer relevant on the game board. Pretty straightforward, right? Okay, so with the script ready to go, we should test this, right? Again, if we go back to 2D view, you'll see we have an export variable for the arena grid because we want to connect to the unit changed signal. So again, I think it makes the most sense to actually test this in action. Let's right click on the arena scene and click on close other tabs to keep things tidy and organized. And if we zoom out a bit, we can select our UI node, our canvas layer, and either press Ctrl-Shift-A or click on this instantiate child scene button and search for traits.tscn. And adding this to the arena scene, I noticed something pretty weird. I don't really want this to occupy the whole screen. So let's open it back up in the editor. And with the traits selected, let's go to anchor presets and anchor it to the top left corner of the screen. Save the scene again with Ctrl S, and if we go back to arena, it's much better. So the problem with that was if we forgot to set this and the mouse filtering is set to stop, then it would cover up the whole screen, so we couldn't interact with anything in the game basically, right? So that's why I wanted to fix this. And if we look at this, we have our 4 pixels margin. Everything looks kind of nice, but what we cannot forget is to actually assign that export variable. So click on the arena grid, select our arena unit grid, save the scene with Ctrl S, and we should be good to go. So let's play the game and see how it looks like. And I do have an error message saying that cannot call method get children on a null value. And I think it's just a misspelling because my trait container is null and it shouldn't be because it's a scene unique name. So let's go back to our traits scene. And yeah, I named it traits container, but in the script I have trait container, right? So make sure to match those two. I'll just rename the node to trait container for now. Save the scene again and let's rerun it because we shouldn't have any errors. Yeah, that's much better. Okay, so if we start buying units now and buy some XP, buy some other ones. Okay, so we have pretty much everything. Just to make sure that these won't be in the way, let's add Robin. And we do have Elf and Ranger added. Okay, so if we add Bjorn, we have Viking and Fighter. If I remove him, you see it immediately updates. If we put in Arthur, then we have Fighter activated and also Noble, but for whatever reason, the icon doesn't display. I think I just forgot to set it. But the bigger problem is that this trait is active. So it should be bumped to the top, right? But it's not. So that's a weird bug. We'll investigate. But if we put in Harry, the elf trait gets activated, and I don't even have an icon for the wizard either. So I think I just forgot to load a couple of textures. And if we put in Arthur too, then the fighter, the elf, and the noble traits will all be activated. So a couple of things we need to fix. We need to fix that the noble is not moved to the top. And we also need to fix these icons, or at least I do because I forgot to set them. So let's close the game for now. And if I double click on the traits, I indeed haven't set the icon. So let's quick load wizard.png. Vikings, okay. Yeah, it's not set for the noble either. So quick load and search for noble.png. Awesome. So now with Control S, this is saved and it should be good to go. And the problem with the noble thing lies in this logic, this update versus creating a trait UI. Why? Well, because when we update a trait UI, we check if the trait UI is active or not. And if it's active, we add it to the active traits. And that's perfectly fine in most cases, but it happens to be the case with the noble that the moment we create it, it actually becomes active because it only needs one unit, right? So the reason why it wasn't an issue with the other ones, because they always need at least 2 unique units to be activated, so they will be updated. And since we took care of this logic with the updates, it worked accordingly. But when we create a new trait UI, we do call the update method, which is fine because if we run the game, you'll see that it kind of works because if we buy an Arthur and put him in, it does light up. So it's not transparent like the other one. So it does get activated, but it won't be moved to the top because we didn't add it to the active traits. So when we move them to the top, it won't be part of that array we consider to be the active traits. And that's a pretty easy fix. We just need to copy this logic to the create trait UI method as well. Because it might happen that the moment we create and update one, it will become active in the case of the noble. So if we apply that logic here too, save the script and run the game again, we should be good to go. And if we buy a couple levels, put in Arthur, you'll see it will be moved to the top. Awesome. So I think that's it for this video, and I'll see you in the next one. Bye-bye.